I'm wearing glasses this year. I guess I'll be making it into the history archive soon. Yes, I mean, we are very interested in the history and in contributing to Catherine's project, but my job, of course, is to look ahead. My job this morning is to spin you another yarn about what we're likely to be doing, or what I think we're likely to be doing in the Dyalog development team in the next few years. This year we've split the roadmap presentation in two, so I'll be doing the first part titled The Blue Hills, where I'm looking years ahead, and John Daintree will follow up with the next presentation, talking a bit more about the details of what we're likely to do in the near future. I know that each year when I do these presentations, I think this is the 7th one I've done now, I do have both the marketing people and the developers cringing a little bit when I talk about all these things that I think we're going to do soon. So I thought this year I'd just put in a slide to put this talk in context. Some of the hills are further away than they might appear. I've reviewed most of the presentations that I've done in the last few years, and I think I can claim that the direction is pretty reliable. I looked at the 2008 keynote in particular. I thought all this stuff would be done over the next year or two, but I'm happy to say that it looks like at least by next year, so 3-4 years later, all of the things pretty much that were in the roadmap presentation in 2008 will be there. All of the things on this slide here were actually mentioned back in 2000. In fact, the component file server as far back as 2006, but that finally also we hope will be out next year. Well, that will definitely be out. That one will definitely be out next year. So everything that follows now, you can think, well, it's going to be there by 2015 or so. And if you want to know when things will actually be done, you should talk to Richard Smith, of course, who we didn't bring along to make sure that you couldn't ask him right now. He's back home making sure that the projects are in fact still moving with the resources still available to him. I think Andy just told me at breakfast that today or tomorrow, we will release the first patch for Dyalog APL ever released during a Dyalog conference. So, if you feel you need any of the things that I mention over the next 45 minutes, before 2015, make sure to point it out, because we're still a small organization and quite interrupt-driven. We listen a lot to what you say, and it has a real impact on our priorities. So here's perhaps a slightly more realistic view of the Blue Hills, and John will be telling you a bit about how to navigate the gravel after the coffee break. So I'm not going to go through all of these in detail now, but I think it's worth taking just a minute to look at what has been done in the last 5 years. It would be too much to go further back than that. But there's a very significant amount of stuff that's been put into the last 4 releases spanning the last 5 years. The release cycle has been a little bit more than a year. We're hoping to bring that down to closer to a year in the future. So in 2006, the key features were object orientation, the 64-bit interpreter. Well, people will disagree about what the major features were. This is my view. Version 12, Unicode, and the APL language bar, which has made APL much easier for new users to get into. Our son had just learned APL just before we introduced the language bar, and when he saw it, he had sort of a slightly wistful expression on his face, and he said, "Oh, it's not so hardcore anymore." XML user commands in version 12.1, those are going to be very, very significant. And embeddable.NET GUI components, I'll get back to. And in the latest release, the regular expression operators that I think are maybe not so important to seasoned users who have found their own mechanisms for dealing with text, but new users coming in with any kind of software engineering education recently will know about them. Profiling and 64-bit arrays. The 128-bit decimal data type, I'm a little bit curious about how many people have looked at that and found that to be of interest. Okay, not a huge number. The complex numbers, again, we didn't have any requests from our current user base to do complex numbers because the people who needed complex numbers were using APL2, obviously, or some other APL system. But again, we think this will make APL more attractive to students in the mathematical field. So having done all that, is there really anything left to do still? This is a slide I put together for one of our internal planning meetings about 6 months ago. It took me about an hour on the plane to whack this up on the way to the meeting. There's a lot of stuff left to do. The blue oval things are things outside APL that we might want to connect to. And then we've got a wide variety of things. We've got sort of language extensions down here, functional things. We've got all the tool stuff in green up at the top. Compilation, performance improvements, large workspaces, files, etc. I don't want to leave that up any longer. I'll now try and organize that into some themes over the next 40 minutes. So, first but not least, something that we really have been putting a lot of effort into recently is increasing the quality of the APL interpreter each release. Our goal is that when we put out a new release, we want customers to be comfortable installing it immediately once we put it out the door. And to do that, we have put in process management. So Richard Smith, as Gita mentioned, is managing the development process. Andy has been doing a massive effort on cataloging and making sure that the development team doesn't just get excited by new features, and also spends a decent amount of time in every release fixing old problems. I think version 13.1 is going to be the first release where we actually spent a comparable amount of time dealing with old issues compared to just throwing new stuff in there. With over 300 bugs officially killed, I think was Andy's latest count. And the release cycle is not complete yet. So what we're doing in an attempt to stabilize things is that in the past, each Dyalog release has basically been you start with a blank page, you decide what features to put in, you research them, you build them, you QA them, you try and put them out, all in an 18-month release cycle. What we're doing now, and what you'll see if you take a look at the conference edition, which is in your pack, is that there's a lot of exciting features that we've been doing research into, a large amount of work in fact, but we're not planning to put it directly into the next release. We're building a research pipeline that Richard will then pick stuff out of, the marketing team will prioritize, and we'll have a longer gestation period for new features. And we can see that this work really is paying off, just the work that's been done in recent releases. I think by September 1st we'd had something like 150 downloads of version 13.0, and something like 100 people had patched it at least once. So people are really adopting the new releases much faster than they have done historically. So that should underlie everything that we do. One thing that we know, the picture theme this year is bicycles. One thing that we know that everybody is interested in is performance. Everybody wants to have their applications run fast. And this is something I think we can commit to, that over the next couple of releases we're going to be spending a significant amount of time looking at performance in addition to just new functionality. We're going to be tuning individual primitives. If you have anything that you feel isn't running as fast as you think it ought to, please let us know. If you have any application benchmarks that can run reasonably standalone, ideally just a workspace and some simple files, no Oracle or IIS required in order to run it, please send them to us and we will include them in our nightly batch run. So your code will be run and profiled every night. We've reached the point now where we build all of the interpreters on all platforms every night and run the QAs. And it would be really valuable to have these customer real code that is important in making your applications run fast as part of our nightly batch that we'll be monitoring. We know that the quantities of memory available and the speed relationship between cache on processors and main memory speeds, those relationships have changed very significantly over the last half a decade. And we're going to be revisiting all of our memory management algorithms and trying to speed the interpreter up in very large memory situations. And we've actually started a project that Jay Fode is working on and we'll be talking on tomorrow morning to look at actual compiler techniques in order to reduce the overhead of the interpreter. And we're also going to be providing a number of we have provided tools and we'll continue to work on providing tools to help you find the hotspots in your applications. I was going to do a demo here, but I think in the interest of time, I'll just show you a screenshot from a tool. This is a user command that's included in version 13.0, built on top of the new quad profile function for monitoring application code. And this is the default mode where you just run your code and you call this dashboard, and it's showing a breakdown by each function, which functions use the highest amount of code as a pie chart on the left, and on the right-hand side, it's showing line by line the highest consumers. And this has a drill down capability, so you could click on any one of these pie charts and go into a small section of the interpreter to see what's the main CPU consumption within a particular part of the application. And even features to look up the stack and see when a utility function is called, where is it being called from. This is unfortunately only available on using our Windows GUI at the moment, but if you're using a Unix platform, you can gather the data on Unix, store it as an XML file, and then import it into Windows and use the tool there. Right. One goal that we have, in addition to just sort of improving the general performance of the primitives and reducing the overhead of the interpreter, is to tap into the parallel hardware that's becoming available. Well, it's sort of parallel. You have lots of parallel cores, but unfortunately we don't really feel that you have truly parallel hardware because the memory is a huge bottleneck. If you want multiple cores working on a large volume of data, they compete for the memory. So although APL is an inherently parallel notation, it doesn't just automatically parallelize to the parallel hardware that we have today. And we are going to have to do significant work to give you the impression that this stuff is just there at your fingertips. You don't have to do a huge amount of work to tap into it. One tool that we've had available for a while is a workspace that contains some parallel operators that automatically run multiple processes. So that allows you to do coarse-grained parallelization of your applications. You have to do some work here because you have to identify the loops in your application and move them into using this parallel each operator, but it's sort of all very much within the domain of the APL language. So you're not having to use any really new techniques. Each should be a well-known concept to APL programmers. There's parallel each, parallel outer product, and parallel rank operators as well. We will also do research, real compiler research, I expect, over the next few years to really, well, the conclusion we've come to is that it isn't really possible to properly, automatically parallelize APL code without compiling it. You need to do data flow analysis in a function to see how data flows from one primitive to the next if you're going to make efficient use of cache. If you just blast everything out onto a bunch of parallel processors, you have very poor cache utilization and you get killed by copying memory around the system. So without some form of compilation, we can't really achieve very high parallelization, so using graphics accelerators, etc. We're going to do everything we can to make this, use just-in-time technology so that you don't have to, take your APL code, move it to some other place, package it differently. Hopefully we can have this happen automatically. When you leave the editor, you've maybe made some mark that you want the function compiled, and it happens automatically. That's the dream, anyway. And one thing we're finding that's related to this is that, and this is something that you can see if you read research done by other programming languages, is that a functional approach to development really helps parallelization. If you don't have side effects, it's possible for compilers to much more easily spot the potential optimizations. So we're going to be, in order to help move the APL developing community in the right direction for us to be able to parallelize the code, we aim to be providing better support for defuns. For example, the new quad profile allows you to profile defuns where the old quad monitor did not. So our tooling support for defuns will be improved. And APL Sharp has a new type of function that we'll be presenting later today that also tries to move people in a functional direction. We really want APL in general to be recognized by the programming community as a tool for parallel programming, because if we can show that APL can be compiled to run with high efficiency on parallel hardware, that will dramatically increase the interest in APL outside of the current community. This is something that could really put APL in the limelight. It's the holy grail that programming languages are searching for at the moment, is putting parallel hardware at the fingertips of people who are not writing highly optimized C++. I actually had a different picture in mind here that Gita wouldn't let me use to show parallel cycling, but I'll offer you a little sneak preview if you're quick. If you know the Queen album Bicycle Race, you can go home and pull that poster out of the LP cover.
I just reminded you it was in America.
There were a lot of people on bicycles, mostly pointing in the same direction. Okay, another challenge related to the parallel issue is that we really want your applications to be able to run in the clouds. We don't yet have a very clear idea how we do this, but the obvious first thing to take a look at that the tools team, I hope, will have time to look at in the next year, Brian, is to take the parallel workspace and see whether we can hook it up to the Amazon cloud, so that you can you do your peach and it just fires stuff up automatically on the cloud. We hope to provide a virtual machine image and a tutorial to show you how you can package something to deliver on at least Amazon's web services. And we're wondering, could we introduce a new kind of license where people can, your customers just pay some kind of runtime license through licensing these virtual machines on Amazon. Amazon has mechanisms to collect the money. And then time sharing really truly will be back once we do that. So there's a bicycle in the clouds. One thing that's also becoming both more important and also actually easier is being able to write APL applications and move them around on different platforms. So that's a Brompton, it's a bicycle made in the UK. You see a lot of these on the commuter trains in the UK. It's amazing. Now, we're in a good starting position because the existing Dyalog APL is built from a single set of source codes. It's binary compatible across all of the platforms that we provide. We've got these 4 variants: Classic, Unicode, 32 and 64-bit. But everything is built from the same source code. You can save a workspace on the Pocket PC, which is a 32-bit interpreter, and load it on 64-bit AIX, and it just runs. You can share component files between all of these, and you can connect APL sockets and transmit APL arrays between any of these platforms. But the IDE and the tools that are available for development on these platforms vary greatly, and that's something that we expect to focus a lot of effort on in the next few years. And also we have the problem that people want to embed software in web browsers, on mobile phones, and so on, which requires something which is technically known as managed code, and that's something that an old native interpreter isn't allowed to do due to the rules that Microsoft, Apple, and others have set up. So the solutions that we have in mind here, I think we previewed this in Berlin. You may have seen it. We have a remote development environment, which is a Silverlight application that will be able to provide a graphical user interface for all of these interpreters, and can also be used in, if you're debugging server complexes where something crashes late at night and you get up at home and try and debug it, you'll be able to attach this debugger to a process which has failed, even if it wasn't displaying a user interface, and debug it. That's another benefit of this technology. We're looking at designing a 2.0 version of our .NET bridge so that we can provide the same kind of object-oriented dot notation, access to libraries, the ability to package an APL workspace as I suppose under Java it's a jar file, under .NET it's an assembly. There are a bunch of object-oriented frameworks out there that we can interface to and dramatically increase the number of tools that become available to APL developers. This would, for example, once we have this additional tooling in place, it makes it sensible to look at, for example, supporting the Macintosh. We haven't done that at the moment because it would be a big job to create our own graphical IDE there, but once we have this technology, it will run on the Macintosh. So we could provide a reasonable Mac version. If we have access to something like Java on the Mac, we could build GUI applications there. And another potentially interesting target platform is, of course, the Linux on the various IBM mainframes and mid-frames, where at the moment it would be difficult for us to provide a development environment. Once we have the RIDE, we can port our Linux version to one of these platforms and provide a really rich development environment immediately. Now, to address the problem of having APL run in web browsers, on cell phones, tablets, we actually need to start a completely new APL project because we need to build an APL interpreter which is designed to run in these managed code environments, which requires a completely new source base because we have to write to a virtual machine framework that they provide. So the most important immediate motivation for the APL Sharp project is to provide an APL interpreter that will run on, on the iPhone, on Windows Mobile, etc. And the new Windows 8 Metro environment, which, although it is it's running on the Windows desktop, Microsoft is placing some restrictions on what type of applications you can just integrate into that environment. We may be able to build a version of Dyalog that will integrate with that, but certainly APL Sharp will easily integrate with it. So just a few more words about that project. Although obviously it's in everybody's interests that APL Sharp at the language level is as compatible with Dyalog APL as possible, the platforms actually dictate some changes. We have to have essentially lexical scoping rules because APL your programming stack, APL is just one language together with other languages that might be on the stack at the same time. So we essentially have to view memory and the stack in the same way that the other programming languages do. And of course, we're not going to move the Win32 GUI and other old-style tools to this platform because the whole point is to use Windows Metro UI or whatever's available for making flashy mobile applications. So what this means that there is really no requirement to be able to just take an existing application and run it on APL Sharp because that doesn't make sense. If you want to use the old style application, continue using Dyalog APL. And this gives us, because we don't have the requirement for binary compatibility, we have some freedom to design a modern dialect of APL. So how would we design APL if we started again? Which is what we have been doing. So the idea is to design a modern multi-paradigm language which blends array programming, functional programming, and object-oriented programming in comfortably, we hope, that's the goal, into a single package. So to be very clear about this, APL Sharp is not a replacement for Dyalog APL. We expect our investment in both of these products will grow in the years to come. Dyalog APL is the mature APL system that handles very high data volumes, very high user loads with very high performance. APL Sharp is if you have one of these specific integration requirements. Somebody asks you to build an application to run in their refrigerator control panel. You would probably want to look at APL Sharp for that. And the idea is that by combining these tools, depending on where you need to deploy your APL system, you have much more flexibility. You might combine the tools. You might write a web server application using web services implemented in Dyalog APL, doing lots of number crunching, and then a user interface on the cell phone in APL Sharp. You'll be able to connect sockets, exchange arrays, share component files, etc. between them, because the interoperability and shared tool layers will be a key design goal. This has been a lot harder than we expected. You may, if you look at where we are now compared to last year in Berlin, you may think, well, we haven't made a lot of progress. We threw away the prototype. We've started again on what we hope will be the production core of this, and we expect now to be able to make several releases every few months in the year to come. And the blackboard has been very useful. In this progress, a lot of blood has been shed. Right, what else do we need? Okay, in addition to having a portable development environment, we also need tools to build portable, or to build user interfaces and other kinds of interfaces that will be portable across multiple platforms and will run on the mobile devices. And that's a little bit tricky at the moment, because Microsoft, if you've been following the debate about Silverlight versus HTML5, Microsoft has been very unclear since about a year ago. There's some kind of power struggle going on at Microsoft, is my reading between the lines. It's very unclear about which of these technologies they really want to push in terms of marketing. I think it's pretty clear that all of these technologies are going to be very important. So in the corporate environment, WPF and Silverlight is going to be very important for 10, 15 years, as long as the cycle for these things tends to be. The HTML5 JavaScript is moving much faster because it's where all the young people trying to build clever little apps are. So that's sort of come up as a dramatic wave over the last year. But we are going to have to look at all of these. And then as the additional twist, Microsoft says they're going to build future versions of Windows for the ARM chip, which powers a lot of tablet devices and so on. So we may actually see Dyalog APL being able to run on a tablet device using Windows for ARM. We don't know exactly what's going to be available. Here's a chart. This is about a year old, where there's a website called RIA Stats, Rich Internet Application Statistics, which is capturing data from everybody's web browsers to see, what plugins do people have available. And we can see here that a year ago, you had Flash up there virtually on every machine. Silverlight had reached just a bit more than half. And Java was on roughly 3/4, it's installed on roughly 3/4 of the machines. I pulled this chart again yesterday, or the day before, and one thing you notice is, there's 4 now. there's a chart called HTML5 Canvas and Video support, which is already on more than 3/4 of the browsers. I think a lot of this is going to be browsers running on handheld devices and so on. That it just popped up from being nothing a year ago to being, after Flash, the widest supported of these rich environments. Silverlight, fortunately for us, has increased very significantly and is up to 3/4, and just about everybody has the latest version of Silverlight. Java has fallen very slightly. If you look at the Java is now available on slightly less machines, and Flash is roughly unchanged. So this is a bit of territory that's quite hard to chart. There's definitely an opportunity still to add a few more bells and whistles to the Win32, Quad WC, the old interface. There are some things that we haven't taken the time to support. But in a recent release, we added the capability to take any .NET control and just throw it into Win32, a classical form. So that means, anything, even Windows Presentation Foundation subforms can be integrated into an existing form, which certainly makes it less urgent to add anything to the Win32 API. But we do think that if we build out the bridge to support object platforms that are available on Linux, AIX, that provides a lot of interesting alternatives. APL Sharp is going to be able to make use of Silverlight and Moonlight on the handheld devices. And recently we have discovered a JavaScript library known as jQuery. How many people have heard of jQuery? The people who were in the workshop yesterday, and a couple more. This is a JavaScript library that seems to be fairly easy to use from Dyalog APL. So we're thinking that we may also be able to find some fairly straightforward mechanisms to build HTML5 JavaScript applications from APL without requiring you all to go out and learn how to do JavaScript. On Microsoft.NET only, apparently, Windows Presentation Foundation isn't going to be available for Mono. But if you're in the corporate Windows environment, that is going to remain important. And then, of course, there's always the opportunity or the ability that many of the corporate users will go for, which is to, well, take your APL application, take the computations, turn them into a web server, a web service, write the user interface in C# or Java or whatever. And with the web server capabilities that we have both via .NET and with the standalone web service, it's very easy now to take an APL function and in a few minutes turn it into something that any programmer can call from any programming language. If you haven't looked at what web services are, you should definitely have a quick look at that and see whether it would help you make your APL solutions more easily available to others. And here's a little screenshot of, this is just a simple example from Michael Hughes's WPF tutorial showing an APL application presenting a WPF front end. So you can hook into all of the new ribbony, bar-y things that are modern with ease. We'll be providing soon a tutorial on using Windows Presentation Foundation from APL. And just briefly, this jQuery stuff is worth looking at. This is one of the advantages of trying to go out and sell APL at non-APL conferences, is that you get to go to a lot of presentations made by people who are not in the APL community. And I happened to go to one on jQuery in Gothenburg, and I thought, wow, this is... So here is a little application to help you plan your week. It ends up suggesting that you should do everything on Monday, but of course that's not what you want to do. So you can, drag things around. I'm going to vacuum on Thursday. Where do I put it if I don't want to do it at all, Brian? Yeah. Anyway, so that's cool. I mean, it's the kind of thing you want to be able to do. Present a nice interactive application. Now, how much APL code do you think it took to build that thing? Well, in the mild server framework that we're experimenting with now, this is all of the APL code required to build that GUI component. So a mild page, which is a bit of script that defines a web page in the mild server, basically just has to have a function in it called render, which ends by returning some HTML. It has to end by saying return and some HTML. And using this jQuery library, we can build a bunch of very small, simple-to-use functions, we think, where you can just build lists like this, build an array of arguments, and build calendar objects, sortable tables, all the kind of widgets that people expect to see on a modern web page. So we're quite excited by this at the moment, and developing little new jQuery gadgets. If you think this kind of thing is interesting, please talk to Brian, look at the mild server, and let us know whether you think this is going to be useful. Right, also worthy of mention, I did mention it before, but I think this is one of the features we've added in recent releases that people haven't really picked up on just how useful it is. So here's a posting from the forum. I guess it's probably not easily readable at the back. But somebody posted a question to say, how do I include a JPEG picture into a Dyalog form? And the Dyalog GUI doesn't directly support JPEGs. I think, JD, correct me if I'm wrong, because of some old worries about copyright.
Yeah, I think they've expired.
They've probably expired, but we didn't put this into the original, quad WC bitmap object. There was no support for JPEGs. Now, obviously, we could add that, and arguably, we should add support for JPEGs. But it's possible, and you can't see that here, but there's one line of code here that just says, well, add a .NET control, which is a system.windows.forms.picturebox, and read the file and display it inside what is a classical Dyalog GUI. So that supports, any image format you can think of, TIFF, etc., etc. We could play a video there, probably not with exactly that control, but there's a media player that we could just have thrown in there, and we could play videos and sound. So all of these, both the controls that Microsoft provides and all of the third-party controls built for .NET, you can just plug straight into a classical Dyalog Windows application without having to rewrite it. You don't have to recast it as a WPF container for the whole thing, or even Windows Forms. You can just plug it straight in. Okay. Integration is one of these words that it's quite fuzzy, but there is a bicycle integrated in a corporate environment. We also want, and these two things are quite closely related, we really want students to like APL. This must be a student, because it could be a professional stuntman. But who would ride a bicycle on beer bottles?
They're actually full beer bottles.
Are they full beer bottles? Right. Does that increase or decrease the likelihood that this is a student? Because as Gitta pointed out, in these four scenarios that we look at, when we try and think about the design of future features, we try and be careful that we're thinking about all these people, because they're all, at the moment, it's these guys who pay us all the money, right? These guys pay, 80% of our salaries or something. So there's a temptation to just listen to them. They just want Visual Studio integration and a bit of Java, and who needs to do GUI in APL, etc. the curious thing is that as a customer pays you more money, they actually decrease the use of features of Dyalog APL. It's the customers in the middle, or the guys who are just getting started, who want to use everything that we provide. And then they lose interest as they move to this layered application approach. So if we just listen to them, we might be able to increase our short-term revenue, but we wouldn't have the domain experts coming in. We wouldn't have students. Well, IT students perhaps, because they would have similar ideas about layered software development as corporations. But the actuarial students and the financial guys and the chemical engineers wouldn't be that happy. So we're hoping that, increasing the integration with .NET, Mono, Java, etc., will take care of a lot of stuff. One of the really good things about the remote IDE is that it's built on a socket-based API, so that there's an API which we can publish, and people can build plugins for other programming languages, environments. We don't have to build an Emacs or an Eclipse plugin. We could bring in a summer intern, a student, to come in and build that for us. And they'd be able to do that. They would understand how to do that better than we could. Saving APL source code in Unicode text files is very, very important. It helps with all aspects of integration with development tools. Visual Studio, Eclipse, if you want to build projects, use Emacs, source code control, management systems. This is something you really want to take a look at. If you can't integrate it because you already have you've built your own source code management system, then look at exporting at least the source code to a management system. Keep the auditors happy, etc. We need to provide access to all these tools that students and others have learned to use. They don't want to feel that when they go to APL, they can't use the skills any longer. We want them to, lure them in and then over time teach them the right way to do things. But we don't want to scare them away, on day one. This is something that's come sort of sneaking up on us. Microsoft SharePoint has become this very, very widely used web service framework. And something we've been looking at, we didn't have to do a huge amount of work to get this to work. Just understand what the error messages meant and then tweak a few things, but that in itself took a while. But you can't read that, but basically that's all of the source code that JD needed to write to integrate his CD database browser as a widget. Again, this is too high resolution, but over here is a CD database browser, which is just a SharePoint web part built in APL. So large organizations will use SharePoint to manage all of their documents and customer relationship management software. And if they want to build something in APL now, all you need to do is build a little script like that, and they'll be able to plug it straight in to appear somewhere in the corporate intranet. Cryptography is getting more and more important. Traditional security mechanisms simply cannot protect data the way, because you're on the web, you're transmitting data over the web. Security is becoming increasingly based on encryption, and the auditors are creeping closer. I don't know how many of you have this risk of having the internal auditors coming to ask about, what is the security of your APL component files and the other data that you use. But we hear from various customers that these guys are sniffing around. You need to look at this to avoid problems with the corporate types. We are providing a cross-platform cryptography library, so a set of APL functions that will run on all platforms and do all of the symmetric, asymmetric encryption that you could possibly want. It's written by Peter Michael Hager, who knows more about cryptography than anybody, I think. The new Conga can handle, this is something we did for a medical application in Sweden, logging on with smart cards to control the encryption of the TCP sockets. And we may look at encrypting component files and workspaces. We don't have a timetable for this. It's certainly not in the next release. But clearly it's one of those things that's creeping up on us. Yeah, I'm not sure what the auditors would say to that one, but so again, Gita mentioned this. The requirements for really shipping, wrapping and shipping applications in corporate environments or on portable devices are getting more and more complex. And the old APL technique of just building all of your interfaces yourself is getting harder and harder. It's getting harder to remain competitive. And while the frameworks like .NET and Java are very interesting and provide a large number of solutions, they aren't always what you want, because often you're going to want to write things that will work across a very wide variety of platforms. I think we're also seeing a little bit of a backlash in certainly the younger part of the development community against the very large frameworks. So people want to run a minimal Linux kernel on a virtual machine somewhere and see how much application they can build with as little as possible. And tools like the standalone web service, our standalone web server, make it possible to use APL to deliver that kind of application as well. And many of the object-oriented libraries really are a bit heavy if you're used to a functional mindset, and we need to build stuff like Quad XML so that instead of going through endless levels of nesting of an object hierarchy to get at your XML data, you can get it out in a nice matrix and play with it. So as Gita mentioned, there's a new APL tools group which is really very significant for us over the next couple of years. Well, and way beyond that. And we're really hoping that by being able to tap into source code in Unicode text files and the structure of the tools that we build, we'll be able to re-engage the APL community in building parts of these tools. So the obvious one would be adding controls for more widgets for this jQuery thing. Office automation tools, we have people helping to provide that already. You've seen David Crossley's and Rick Proctor's workshop yesterday. WPF samples, etc. We need help to provide all the materials that people are going to need in the years to come. So talk to Brian. And above all, if you want to think about designing the next bicycle, we must never forget that at the root of APL is this notation that allows people to express good ideas. And every APL application that's really become significant had some real clever idea that APL was able to help give birth to. So all of these technology things should be there, but they need to be ignorable. This applies to APL Sharp as well, even though it's harder in that environment due to the constraints of a very object-oriented platform. We're doing everything we can to make it possible to ignore .NET and just use APL Sharp as a tool for building domain-specific notations. Fortunately, there's a nice connection between functional programming and parallelism and compilation. So there are some goals that dovetail quite nicely here, in that some of the things that will be very good for the domain experts are also going to be very helpful in achieving the goal of making use of parallel hardware. So we're looking at, and you'll see presentations this week on function trains, closures, which are sort of a functional form of object-oriented programming. The A functions, the rank operator is also a way of expressing loops in a functional way. And we may look at further extending the numeric domains that APL is applicable to, like rational numbers, special functions to deal with prime numbers for people who want to play with cryptography algorithms, etc., rather than just using what's in the libraries. Designing the next set of cryptographic algorithms. So, we can see the hills. Well, I pretend I can, anyway. The road to get there may be long, but the team is certainly more capable than ever before. The sheer numbers, if nothing else. But I think the quality of the people that we've been able to attract, you know, the average IQ of Dyalog has not decreased by going from 4 people to 20, I think. I'm sure that things will not go exactly as I expect. And we do hope that we have understood your priorities, because well, I hope you're not actually looking for this, but if you do, there's a roadmap session, interactive roadmap session, one of the last sessions on Wednesday. If you feel you would like to make a statement, talk to Andy. He's like the toastmaster for that presentation. Depending on how many people say they would like to make a contribution to prioritizing things or pointing out things that we just plain forgot, talk to Andy, and we'll try and I think it might be something like 3-minute slot. Ideally, 10 people talking for 3 minutes, and then we have an opportunity to give you some feedback. There's a lot of presentations, mostly today, that will fill in some of the details of this roadmap. John Daintree is going to continue after the break. Andy, John, and Roger are going to introduce the features in the conference edition after lunch. Jonathan's going to be presenting APL Sharp after that, function trains. Then we split in the afternoon, and there's sort of a functional stream in here with John doing function trains and Roger on rational numbers, and Brian and myself talking more about tools. That'll be upstairs. And this evening, we'll be trying to sell you some more functional Kool-Aid. And then tomorrow, Jay Fode's talking first about the tools that we provide to help you monitor APL, and then some of his ideas for parsing more efficiently and perhaps compiling APL. Following on in that stream, Bob talking about his work on compiling APL for very high parallel efficiency. Sasha Skolmarokov is going to be talking about we have a new experimental interface to R. So if you're interested in doing statistics from APL, this gives access to a very wide range of statistical functions, plotting packages, etc. And then on Wednesday, Michael doing a cut-down version of what was a workshop yesterday on Windows Presentation Foundation. John Scholes talking about closures again, which is an old idea that we think now is starting to look more interesting again. The interactive roadmap session, and then in the afternoon, 3 workshops again. Dan's going to be talking about user commands and other productivity tools. Brian on using the cryptographic library and other ways to build secure applications. So if you're worried about the auditor coming to knock on your door, you want to be there. And then finally, for people who are interested in just finding out how to use the conference edition or want to talk about the features in it, come to the conference edition workshop. Right, and after the break, the gravel and what lies behind it, John Daintree will be taking through us what's a little bit closer than many of the things I've been talking about here. Do we have time for questions? Or nope, I'm 1 minute over. Time for coffee. Thank you very much.